Good evening. So today what we are planning is we'll take a walkthrough of this paper. The title of this paper is Text to Image Synthesis with Generative Models, Methods, Datasets, Performance Metrics, Challenges and Future Direction. The authors of this paper are Sarah K. Al-Habib and Amal A. Al-Shargabi. Why we are doing this is many of the students demanded or requested any possibilities of projects in this new domain called as generative AI. So we felt this is a good paper, and whatever we are doing is we are taking a walkthrough, and we are acknowledging that these are the authors, Sarah and Amal, and this is their paper which we are trying to walk through. Not the entire paper, but the key points, small takeaways we'll try to fit in. So as you can see here, in the title of the paper you have text to image synthesis. What text to image synthesis indicates in generative models is the input is a text at the prompt. The image generative model will be generating output images. So that's what this title says, text to image synthesis. When we are speaking about generative models, we are speaking about, for this task, text to image synthesis, which generative models are suitable, what data sets are suitable, what performance matrices, what are the challenges and future directions. Coming to generative models, we have derived this term from generative AI, and we had seen the introduction of generative AI in my previous video. The link I'll put in the description. We had started with definitions of generative AI, which we said that novel content will be generated, machine learning will be used, the applications can be content generation, code generation, and the related evolution of OpenAI, then GPTs, then DALE, and many more applications we had spoken about. This is how generative models had evolved for natural language processing, CNN, then recurrent neural networks, long short-term memories, gated recurrent units, RNNs. Then the transformer network architecture evolved. So that's how pre-trained language models came, and that's how your chat GPTs and their related got so famous and talk of the town nowadays. But basically it started here, wherein we added some memory to recurrent neural network. The memory there is short, then we added long short-term memory, then came the transformers. And what exactly are transformers? We had introduced the transformer term also. It has encoder decoder architecture. For this you can refer this paper if you want to understand what a transformer architecture is. Basically this is the most well-known paper everybody is recommending to read, because from here that journey started, and here the keyword is attention, and the architecture diagram is there in this paper. You can see the architecture diagram of the transformer. You have encoder and decoder. You can see the encoder on the left and decoder on the right, and the major components are positional encoding and attention, add and norm. So, and this attention actually is related to context. So that's what we are speaking about. So transformers, as seen in the diagram, have encoder decoder architecture. And if you look at chat GPT, It's a stack of decoders, so it is only decoder based. Basically, what happens is you have encoder decoder models, you have only encoder models, you have only decoder models. That varies depending on the application. And how what exactly happens is the input you are giving, and you are giving the input to the transformer, tokenization happens, numeric IDs are given, they are given to the model, the context is understood through word embedding, and output is given. And that also leads to discussion of LLMs, large language models, which ChatGPT is part of, and they are all part of deep learning, is it not? And they are used for this. I'll not go into detail here because that is all there available in my previous video. So what we need to understand is this paper will be telling us about the text to image synthesis methods, data sets, performance metrics, challenges and future directions. And we are not going to read the entire paper, try to understand, but we'll just highlight the uh, keywords and we'll try to connect with that. If you look at the abstract tells about text to image synthesis, which is nothing but words are converted into images. Then it tells about the methods for text to image synthesis like GAN, generative adversarial networks. So, which are at the top. But diffusion models have overcome the disadvantages which GAN might have, and their results are seeming to be better as per the authors Sarah and Amal in this text to speech synthesis. So, as far as text to image synthesis is concerned, uh, if you give a text description, image will be generated. That's what is the context. This is what is the general architecture. At the prompt, give the text, image generative model will be generating the output image. Here they have listed out the traditional methods for text to image synthesis from the literature, say story picture engine. So, what it does is it will be complementing the narrative with appropriate visual representation. Then you have text to picture synthesis system. Then you have word to image. This will be, as mentioned here, giving the compilation of images obtained from Flickr. You have words eye, which is a text to scene system, and then many more. So basically here it is listing out the traditional text to image synthesis methods. Now coming to the new methods for text to image synthesis, deep learning approaches are there and generating models are being used. So what generative modeling here is referring is generating new content, novel content. Okay, you will be giving the input data set and a new content will be generated. So the applications usually related to this are deepfake images or fake images, identifying whether the image is fake or not, kind of. The four major types of generative models being mentioned here: generative adversarial network, variational autoencoder, flow based model and diffusion model. Coming to generative adversarial networks. So what generative adversarial network consists of is the word adversarial. Adversarial is derived from adversary. Adversary indicates an opponent, a competitor, an enemy. So why this word is incorporated in GAN is because it has two components. GAN has two components. One is an encoder, one is a generator, and other one is a discriminator. What is the role of generator here is it will be creating new fake images, and the input given to that is noise vector, and it will be coming out with new fake images. What is the role of a discriminator? The discriminator will try to identify whether the image is a real image or a fake image. Maybe it will be returning 0 for fake image and 1 for real image. So that's why they are adversaries. The next technique mentioned here is variational autoencoder. So they'll be using probabilistic frameworks. Okay, the input is encoded. Uh, One type of encoding may be compression by reduced dimensionality. So what they basically here happens is encoding and data representation. Then next model being mentioned is flow-based generative models. What they do is they'll be learning the encoders and decoders. A transformation is employed to the data depending on the parameters supplied by neural networks. Then comes the diffusion models, which are more popular now than GANs. They say they overcome the disadvantage of GAN model, and the results are better than the GAN model. So if somebody speaks about computer vision and or text to image synthesis, we should definitely explore diffusion models or GAN models also. Now coming to what data sets are more frequent in this text to image synthesis is that is mentioned here. Say for example this COCO data set from Microsoft. I'll just Google one data set here, but you can explore the others. This COCO data set from Microsoft, and you can check. I just click on few of them, and it means that whatever the data sets are mentioned, you can easily Google and download and use them. So what this COCO data set is, common objects in context. It has images, and there are 3,30,000 images, 80 object categories, 5 captions. They are used in computer vision research. They are used for training and evaluation. Similarly, you have other data sets like CUP 200 2011. This is a data set related to birds. We can see somewhere, yeah. You can see here this CUP 200 birds data set, and there is an annotation here, caption here. This is a black bird with orange wings and a pointed black beak, kind of. So like that. So it also has 200 subcategories, these many images. These are the training data set. This is the testing data set. So similarly, there are other data sets like Oxford 102 flower data set, then multi-modal Celeba HQ, Celeba dialog data set, deep fashion, ImageNet, all these data sets, and they have some features like how many number of images, for what they are used, open images, and part of them CCI 12M. Now coming to text to image generation methods. If we are using GAN for text to image synthesis or text to image generation, what it indicates? Input is text, output is image. Simple. Previously, the traditional methods for image generation used class labels or captions, but they could not incorporate pose or location. While GAN and its variations like generative adversarial what where network uh, could incorporate that. So similarly, you have stacked GAN, which is one more variation, which has two stages. There is stage 1 which generate low resolution images, and there is stage 2 which generate high resolution images, and the results of stage 1 and stage 2 are compiled and given. There was one more variation of stacked GAN called as stacked GAN plus plus. They use generators and discriminators. They use tree-like structure. They'll be generating images at multiple scales that fit the same scene. Now, further accuracy is brought with the help of attention GAN here. They are attention driven. You have seen the word attention here also in this paper title, right? Attention. And you also know that if you look at the architecture diagram of transformer, the major component being mentioned is this attention component. So, and when we speak about attention, it indicates context. So, and when we speak about context, if a sentence is given, the meaning of that sentence changes depending on the context. That's what. So, the model has to learn to understand the context also. Then you have mirror GAN. So, if you look at this table, these are the various data sets which we had just mentioned. What are the tasks they perform, like object recognition or classification or multimodal research. Then details like how many number of images, captions, training images, testing images, object categories, all these are mentioned. And architecture diagrams of stack GAN and its variations are given here, which have the major components called as generators, discriminators, augmentation components. We'll skip this and we'll try to go further. Now, if you look at the previous discussion, we had seen text to image generation using GAN. Here, text to image generation using diffusion models. And if you remember the discussion, the conclusion derived by this paper was diffusion models are more successful than the GANs as far as results are concerned. GAN based models work on small scale data. If you look at DAL-E from OpenAI and Party from Google, they are that examples. If you look at diffusion based models, you have VQ diffusion, VQVAs, then you have DDPMs, then you have the author's contributions being mentioned as they use CLIP model. So, and its variations. These are the diffusion based models which are listed out, starting with VQ diffusion till DeVry. I'll go for the evaluation metrics. The two major evaluation metrics mentioned here are Frechet inception distance and inception score. So, this is the formula for that FID, and this is the formula for inception score. And if you look here, what we have is covariance values, mean values in the formulae. If the score is lower, then it seems to be better, more accurate. Inception score, what it does is it will be calculating the faithfulness and diversity of the distribution. This is the difference between marginal distribution Pi and conditional distribution Pyx, and they'll be using KL divergence. The image is predicted using a pre-trained inception V3 network. If the IS score is higher, that indicates better. This table just lists out the FID scores. Below this line, all the models are diffusion models, and above this line, all the models are GAN variations. And we had said that the lower the FID score, better. It means all the diffusion model based models are showing lower scores than the GAN based models here. There is one more matrix called as R precision. What it does is it will be checking the consistency between the text and image. Here challenges and limitations are listed out, which I leave it to you, including the future directions. Why this effort is just to sensitize you guys to this new project possibilities for your undergraduate or postgraduate, and hopefully you'll be reading this paper, studying it better. This was just a small walkthrough. Thank you.